Hello. Hi, good morning. You all can still hear me? I can hear me great too. Thank you so much. I know it's always really tough to come to the first talk the day after the party. I might have missed many talks the day after the party as well, so thank you so much for being here this morning. Thank you, Maxim, for the wonderful introduction. My name is Huyen. I've been an Android developer for about 6 years now, and I am a member of the Android team at Trello. So I absolutely love doing layouts in Android. They're one of my favorite things about the platform. And I think what I like most about them is the fact that you start off with these really simple XML files, and XML is not a fancy technology, it's been around for some time. And from these simple XML files, we get these beautiful and innovative and expressive applications that we make. And it's also funny to me because in the Android community, you'll hear a lot of discussions about performance. And usually we'll talk about things like Java code optimizations and reflection and enums, depending on who you ask. And at the same time, though, layouts and UI are such an important part of performance and building wonderful experiences. So the kind of what I want to do with my talk today is talk to you about why layouts matter so much to performance, and what do I mean when I say that we should be creating lean layouts, and how they can drive the performance and experience of your applications. And so a lot of times, part of building performant UIs and building performant applications is being able to find problems. We're not, hopefully, well, I guess not too many of us are psychic. We can't always tell where the problems will show up. Sometimes they just do. And so an important part of building efficient layouts is being able to find problems. And once you find problems, you should be able to fix them. And we'll talk about how you can fix some problems with performance in your layouts. And finally, we'll talk about good practices. So normally people say best practices. For me, I like to say good practices because what's best for you and your team and your app depends on your team, your app, the time of the year, like how the stars are aligned. So we'll talk about some kind of rules of thumb that might help you build efficient layouts. So why do we need to build efficient layouts? Why should we build lean layouts? So lean layouts matter because as you might have heard in the Android community, perf matters. So perf matters is this kind of like idea that performance matters and that we should be building applications that are performant and that use as efficiently resources as possible. So when we talk about performance, we talk about resources. And the resources we usually generally talk about in regards to mobile applications are resources like memory, CPU, battery. And with layouts, the resources used by that layout are directly proportional to the complexity of that layout. So when I talk about complexity of a layout, I'm talking about strictly the number of views, because each of those views have to be instantiated into memory. So the number of views will be directly related to the memory that that application uses. And I'm also talking about the depth of the hierarchy. So if you're experienced in building Android applications and have built many user interfaces, you know that sometimes, depending on what your designer wants your application to look like, you can start nesting views and have views within views and views within other views. And as you continue to do that, that depth of that view hierarchy continues to grow. And that also leads to complexity within your layouts. And really, what we're talking about when we're talking about complexity, when we're talking about depth, when we're talking about the number of views, is we're really talking about how many times two methods get called, and that's on measure and on layout. And these are methods that called in the process of bringing those views, bringing your layouts to life onto the screen. And really, at the end, what happens is that you could write 100 apps, 1,000 apps, where these two methods work just fine, and you have no performance problems. But you might write an application, write a UI that's might be particularly complex, that might be very dense in the information that you're displaying, and you might have some performance problems. You might end up with a janky UI where frames are dropped or frames are delayed, and it's just a stuttery, unpleasant user experience. So in the end, building efficient layouts, building lean layouts are very helpful to user experience. But it's not just the users that benefit from lean layouts, it's you as a developer as well, your experience as a developer. And the main reason why is maintainability. And the leaner, more efficient your layouts are, the easier they are to maintain. So just straight up readability. The less views you have in your XML file, the easier it is to parse. The less nested it is. I mean, if you imagine sometimes in Android Studio and you have a bunch of views nested in views, each of those views get indented, and if you start indenting and nesting, soon that code ends up off the screen and you can't read it. So in a very literal sense, efficient layouts tend to be easier to read. But even more than that, maintainability, readability leads to stability in the code. So think about a relative layout, which we use all the time. Now, relative layouts are a layout in Android that allow you to be very expressive and to express relationships between views. You know, this view is to the left of that one and above this one and centered in parent. And that's all really great and it allows you to express your UIs. But the problem is that when these relationships between views become very complex, that means the layout becomes very unstable sometimes. And you can maybe change one view and move it just a little bit here, or maybe just take it away, and then everything else kind of tumbles and crashes down to the ground in terms of your UI. So the more efficiently you can express yourself, the more stable your layouts will tend to be. So before we kind of get started, let's review really quickly about how this process of taking our XML files to the screen works. So the first thing that happens is instantiation and inflation of your views. That XML file, all those elements in it have to come to life to the screen, are instantiated into memory, and this hierarchy, this tree of views is formed. And before that tree is actually rendered to the screen, a few things have to happen. First, that view has to be, or that hierarchy has to be measured, then it has to be laid out, and then it has to be drawn. So all of these are basically depth-first traversals of this tree. So starting from the parent, going down to children, to children's children, all the way down, these three different things happen to each node in that tree. So what happens in measure is that starting at the parent, each parent kind of asks each child to measure itself or tries to measure out its content based on its children. Generally what happens is the child calculates its content, its measured dimensions, sends that back, kind of stores it inside of itself where the parent grabs it later. And usually because we're talking about trees, because we have children of children, usually the children will recursively call their children, ask them to measure, use that in its content, all that kind of great stuff. So after a hierarchy is measured, it needs to be laid out. And basically what happens during the layout phase is that each parent sizes and positions each child. And then finally, once all that happens, we get the draw phase in which your view is actually drawn to the screen, parent draws itself, and then asks each child to do the same thing. So that's pretty straightforward. And again, you could write 100, 1,000 apps where this process works really smoothly. Nothing ever happens. You're happy, your users are happy. So when do problems occur and why do they occur? Well, a couple different reasons. So the first thing that I mentioned a little briefly before is that the complexity of your layouts increases as the depth increases. And if you have a view hierarchy that's very long, that has a lot of nesting, basically what happens is all that recursion, all that, like having all that depth first traversal, increases the complexity because of all that recursion, all those like different parents that have to talk to different children and so on and so forth. Now, another big place where these measure and layout passes might get a little bit out of control is when change happens. So if you look at this little kind of tree that I have here, there's this little pink child, and that child might change. If it changes size, if it changes position, what happens is that now the size and position of that child is invalid. So those two qualities get invalidated, and that child has to be remeasured and relayed out. But it doesn't quite stop there, because if you think about your typical Android layout, when a child, or when some view changes size and position, generally any siblings that it has probably will change size and position as well. And so if one view is invalidated and has to be remeasured and relayed out, its sibling does as well. But it doesn't stop there, because the parent of those two views probably has to be measured and relayed out, because it will also change size. And then, so this process happens all the way up, kind of just traversing up to the tree all the way to the root. So what happens is anytime something changes in your view in terms of size and position, you'll get this chain of invalidations and having to remeasure and relay everything all the way to the top. Now, that's, that happens, and unfortunately, change is not something we can avoid, because what's animation but change, views change size and position and move across the screen. And, we can't really avoid animations either. We live in this world now where we talk about material design and motion design, and we want things to be, elegant and move and communicate things visually to the user. And so we can't avoid animation, which means we can't avoid change. So generally, if you're going to build rich, beautiful apps, you might run into this problem at times. So another place that problems can pop up is with the Android platform layouts themselves. So sometimes layouts in the Android platform just require multiple measure layout passes all on their own. So relative layout, which I mentioned before, which is a really powerful layout that allows you to express relationships between views in that hierarchy, that relative layout will automatically measure and lay out twice. And that is because of that flexibility, that expressiveness. It just basically it basically needs those two passes to fulfill all those constraints that you set out for it. So, you might say to yourself, well, that's not bad. One extra measure and layout pass shouldn't be, too terrible in my performance. But imagine a relative layout inside of a relative layout. While that parent has to measure and lay out twice, that child gets measured and laid out 4 times in the process. And as you can see, it's not really an additive effect, but a multiplicative effect. So the more you nest, the more problems like this can just multiply and multiply. And those measure and layouts, which seemed pretty efficient when they were just on their own, become just exponentially worse in terms of performance. So another place where you might have performance problems are lists. So what is a list really? But a single list item copied multiple times over. Now, if that list item is really simple and very efficient, probably not a problem. But if you have a list that has really complex views, that is expressing a lot of data, very dense data, you can kind of very easily see that it can become a problem very, very quickly. So the interesting thing at the same time, though, is that all these things that I'm talking about, they don't just show up in isolation, in real life. They tend to roam in packs, like, wolves or something. You'll animate something in a list, and the list has multiple copies that are all animating. And so while, again, you might not always have performance problems in your layouts, when they show up, they just show up all together and cause bad user experiences. That's why sometimes it's important to think about layouts in an efficient, lean kind of way to kind of avoid this like snowball of problems. So now that we talked about why you might want to work with lean layouts, let's talk about how do you find problems. When these problems show up, how do you find them? So there are a lot of really great tools for finding problems in your layouts. So one of the first ones that I like to use, and one of my favorites, is what is called the hierarchy viewer. It's an SDK tool. It's been around for a little while. And basically all it is a visualization of your hierarchy. It takes that layout and represents it as a tree. And it can be found in the Android device monitor. It used to be run from command line, but now you can just grab it right from Android Studio. And basically, it just allows you to get a really nice high-level view of what's going on in your layouts. A couple of tips. It's usually best to run Hierarchy Viewer on a physical device running 4.1 and up. If you run 4.0 and down, sometimes it doesn't quite work. If you have an unlocked phone, it's all right, but sometimes you have to run a separate local server for the view. So generally, the best case to use it is physical device 4.1 and up. And another thing that you need to know is that the hierarchy viewer is a visualization, but it has a lot of numbers on it. It tries to estimate how long measure, layout, and draw take. Now, I gave this talk previously, and Chet House from the UI Toolkit team stopped me afterward and said, wait a minute. I need to tell you something, please don't cry. The numbers in hierarchy viewer are completely wrong, don't use them. So, so I didn't cry, but I just wanted to communicate that to you, that if you do use hierarchy viewer, that you should not pay attention to the numbers. So I have a quick example of a view. Is it playing? Right, so this is a view, an example layout that I made for you. I was particularly hungry when I made it, so there's a lot of pictures of food. And as you can see, it's a lovely layout, but it might be hard to see from the back, but there's a little bit of jank there, a little bit of jitter. Now, part of this is that because I have several images, but part of it is because I made the most disgusting, inefficient layout for you as possible. You're welcome. So what I'd like to do is show you what this pretty on the outside, not so pretty on the inside layout looks like inside. So here's the hierarchy viewer. So basically you just start up the Android device monitor from Android Studio. And what you do is usually you'll see in this tab a list of devices. It's just my little emulator there. And what you do is click on the hierarchy viewer tab, and what you'll go to and see all the active windows on your device. Click the activity that you want. And at some point, you'll get this nice tree visualization loading up. And you'll have two views. You'll have a nice overview, and you'll have this kind of detail view where you can kind of navigate around. And the nice thing is that when you click on each node in your tree, you'll actually get this little preview of what the kind of portion of your UI that is controlled by that node and below showing up there. So you can get a really good idea of where problems are. You don't just see the structure, but you can see what the final rendering is. And as you can see, there's a couple of numbers that pop up. Again, don't ignore those, or Chet will come and make you cry. But again, it's a really good place to see where problems are from a high level. So if you look at that tree and you see that it's very, very long, you can maybe say to yourself, oh, my view hierarchy is very deep. Or if you see just a lot of those little gray boxes kind of hovering around in one area, you can say to yourself, oh, there's a lot of views right there. So it just gives you a really good idea where to start to find problems if you have them. So the hierarchy viewer is great, but it's actually going to be replaced at some point by kind of one of the new tools that came out in Android Studio 2.2, and that's the layout inspector. And really what it's meant for is to examine and debug the rendering of your layout, so looking at styles, looking at attributes. But it's also not a bad way to look at your view, your hierarchy again from a high level and see where problems might be. It's kind of slightly separate from Android Device Monitor. It's in the Android Monitor tab that you might have at the bottom of Android Studio. And even though it's really meant for debugging kind of styling and theming, it does give you a really nice view of your layout. And as you can see here, I'm in the design view. And down here in the Android Monitor tab, there's a little green button where if I have an instance of my application running, I can hit it. I can click at any activities that are active on the backstack or on the stack of that application, and Layout Inspector will go ahead and actually show me basically a snapshot of that activity. So as you can see here on the left, there's basically kind of a textual layout of that hierarchy. And it's a really good way to see, again, if the kind of names of components is way out, kind of coming over to the right side, you can say to yourself, oh, my view hierarchy is really deep. If you just happen to have a lot of stuff in that list, again, that shows you that you're having a lot of views. And what's nice about this is, again, you can kind of click around, kind of examine maybe like where things are, examine the properties. And kind of just a nice high-level thing with design view is that now we have not just the rendered design view, but also this blueprint view. And as you can see here, you can kind of see where the views are starting to overlap and you can't even see the names anymore. Again, just a really good way to look very quickly and see where things are overlapping, where things are very nested, and maybe to kind of get a hint about where your problems are. So if you're into numbers, there's quite a few tools that you can use. I won't do too many examples on these, but there's Systrace, which is a tool that gives you basically a lot of execution data for system and application processes. It's also in the Android Device Monitor, and basically it traces all this kind of process data and creates interactive reports. Now, I mentioned jank before, but there's actually kind of like a quantitative way to talk about jank. So a smooth UI we kind of consider to run at 60 frames per second, which means that each frame has to run in about 16.6 milliseconds. Now, what happens when your measure and layout start doing too much stuff and taking too long is that it will take longer than that 16.6 milliseconds to render the frame. So if it takes way too long, that frame gets dropped. If it takes somewhat longer, then it'll get delayed, and that's where that jank, that's where that stuttering comes from. Now, Systrace actually will show you the frame renderings in that interactive report, and what that looks like is something like this. So when you run Systrace and you ask for kind of like the view kind of drawing data, you'll get these really nice dots. It might be a little bit hard to see from the back, but each of these green circles has an F in the middle, and that's the rendering of that frame. And generally, if the rendering of that frame is within that 16.6 milliseconds, you'll see a nice green F. If it starts to get kind of bad and slow, you'll see yellow to red. And you'll also generally get some really nice alerts and other information that comes up in these windows in the bottom. So if you're really looking to kind of get down to like the frame level of where problems are happening, maybe with scrolling or things like that, you can use Systrace. Another great tool to use when you're trying to find problems and like numbers is DumpSys. DumpSys literally collects and dumps what the documentation calls interesting information about the status of system services. And it just gives you a lot of numbers is basically what happens. So there's a couple of different ways to use this. If you want kind of like an aggregated analysis of how different frames of animation are performing, you can use DumpSys with this gfxinfo argument. And again, you get kind of like this kind of like small report about maybe how many dropped frames you have, things like that. In Marshmallow, there was actually an argument added, and that is you take the same GFX info call and add frame stats to it, and this gives you incredibly detailed timing info for the frame. You can tell exactly when this happened and when that happened, and super analyze maybe how long different traversals of that tree as it's getting drawn take place. But if you don't like using command line tools, or you just want things to be a little bit more kind of integrated with your development, there's this really cool new API that came out in, I think it was Marshmallow as well, called the Frame Metrics Listener. Actually, it might have been Nougat. I think it was Android 7, so it's Nougat. But basically, Frame Metrics Listener is an in-app API that allows you to, again, determine really detailed information about the frame rendering, and it's basically equivalent to that GFX info frame stats that DumpSys does, but it gives you this nice PubSub API that allows you to access that frame information for your current window in your application. And what's also really great about frame metrics listener is that when you run the ADB DumpSys GFX info frame stats, it limits itself to the last 120 frames of information. Frame metrics listener is not limited to that. So again, if you want to really measure and get metrics and really kind of benchmark how your applications are doing, frame metrics listener is a really great tool to use. All right, so those are some tools for finding problems. Let's talk about how you fix them. So I always like to start simple when I'm fixing problems. Problems when they show up, I tend to panic, but the best way to handle panic is to start simple and start at the beginning. And my beginning is usually talking to lint. So I will love lint and hate lint depending on the day and how much coffee I've had. But generally, when you're trying to make your layouts more efficient, making lint happy is a great place to start. And lint tends to complain about things that are not good ideas. And when you're having troubles with layout performance, usually they're great places to start first, good things to look at for the first time. And they're usually like really straightforward things, like things you've probably seen complained about all the time, like don't nest weights, don't have views that serve no purpose, useless views, and don't nest things too deep. So I have this lovely, lovely application where I have different examples of things that lint will layout you for. This pink monstrosity at the bottom is just nesting with a nesting with a nesting, if you're kind of curious what that was. So let's take a look at what the code looks like and what lint says about this code that made up this lovely layout. Now, one of the things that lint will yell at you for and that you should definitely fix are useless parents. So it might be a little bit hard to tell, but what I have here is a relative layout that has some nice padding, and I have another relative layout in here, and I covered it up with the lint warning, but basically there's nothing to that relative layout. There's no padding, there's no background, there's no graphical or layout kind of attributes that I set there, and then I have a text view inside. And relative layout lets me know that that inner relative layout is useless. It serves no purpose. And in fact, all it does is to increase the amount of work needed to measure and lay out that section of my UI. And lint is correct. That needs to go. It doesn't serve anything. And just removing that, the UI renders the same. And I actually have reduced the depth of my hierarchy by 1, which can be massive depending on what that content is. So another thing that lint will yell at you for is nested weights. Linear layout actually has been my favorite layout for a long time because of things like weights, where you can ask that certain views get available space distributed to them, with different ratios. The problem is that with that flexibility comes, possibly a lot more calculations. So here I have one linear layout, and that's inside of another, and both of them are using weights. And lint is letting me know, hey, nested weights are bad for performance. And if you think about it, it's not too hard to see why. So what happens is when you use linear layout with weights, you get this flexibility to distribute the available space between different views. But that flexibility, that distribution basically creates a kind of level of unknowns, this little ambiguity. So what happens is when you nest weights, you're multiplying multiple levels of ambiguity together, which makes it more work for the linear layout to resolve that. So again, that's why it tends to be pretty bad to do this kind of thing. And in my personal experience, after doing things like this and screwing up a lot, is that if you are doing nested weights, there's always a better way or a different way to render that particular design or that particular structure in your UI. So too much nesting. So lint will actually warn you when you've nested too much. So here's that layout, and here's that pink monstrosity. And as you can see, I've got linear layouts within linear layouts. And here's what I was talking about earlier, is when you nest too much, that code starts to go all the way over to the right and all the way to the right. And, oh, no, it's off the screen. So lint will actually yell at you about overly nested views. And there's actually an environment variable inside of Android Studio called max lint depth that I think is set to 10. Now, if you are nesting deeper than 10 levels, I would strongly suggest that you kind of reevaluate and try to make your layout a little more efficient. Again, when you're getting to this level of depth and complexity in your hierarchy, you're just making, again, a lot more measured layout passes, and that exponential kind of snowballing effect tends to happen when you're nesting this deep. And again, it's it's harder to read. So another way to kind of fix problems if you've made lint happy and you're still having problems is just to simplify. And that's really what the idea with lean layouts is just to simplify, reduce, do things as efficiently as possible. And I kind of tend to think about it as an engineering challenge. If I get a design comp from my designer, what is like the most efficient, the most kind of interesting way, in a simple way, that I can do this? So take it as an engineering challenge. So, you know, as developers, you probably know that whenever you have a problem, there's many, many different ways of solving that problem. When you're talking about layout performance and lean layouts, always try to pick the simplest one, the kind of leanest one, the one that takes up the fewest views and the least nesting. So there's a lot of different ways to do this. Sometimes what you can do is instead of using views, you can use attributes in the XML or just other techniques that replace multiple views with just kind of like a little more code or a few more attributes. So let's take a look at an example of that. So here's something we see a lot in Android, an icon with some text. Now, I know when I first started Android, I would say to myself, oh, I'll use my favorite layout, linear layout. I'll create a horizontal layout and a horizontal linear layout. I have my image view, I have my text view, and that'll render perfectly. And that's not an incorrect way of doing it, but you don't have to do it that way. And in fact, Lint will yell at you when you do this kind of layout with an image view and a text view, because there is something that you can do that is simpler and more efficient. Now that's what are known as compound drawables. So compound drawables are these attributes on text views that allow you to render a drawable to the left, right, top, or bottom of that drawable. It even has like a really great attribute for padding. And rather than using 3 different views, so here, like the way I would do it, we'll call it naive implementation of it, with the linear layout, image view, and text view, if I just use compound drawables, I can take it down to 1 view. So I've eliminated 2 views and 1 level from my hierarchy just by using these attributes, just by using drawable, left, right, start, end, and drawable padding. I can just really simplify things very easily. Now to go back to my example, the top one, the top like image and text is done with the horizontal linear layout. The one directly below it is done with compound drawables. As you can see, the effect is exactly the same. And if you look in the middle, I have an even more extreme example. So in the middle, I have some text with arrows pointing to the top, left, right, and bottom. Now the first one is done the naive way with, I think, a frame layout or something, where I kind of position 4 image views and a text view. So that's 5 views. Now if I just use compound drawables, which is what I did for the text and arrows directly below it, I now have just 1 view. So as you can see, as things get more complex, as you try to do more interesting things, it becomes much more important to do these kind of little things and little kind of optimizations with your layout. It can save you just so much. So here's something else. This is a conversation that I'm trying to render. So I have 2 styles. I have one person, say, talking over here, and one person talking over there, and I have different styles. This person's talking in like white text, this person's talking in yellow text. Now, if I saw this like first part where I have kind of 3 blobs of text when I was first starting Android, I might say, well, that's easy, right? 3 text views, one here of the first style, one here of the second style, and then a third one of the first style again. So that works, that's straightforward, it renders correctly, but you don't have to do it this way. In fact, I can render this kind of conversation, this back and forth, these different styles, with 1 text view. And I can do that using what are called spannables. Now, spannables are this really cool tool in the Android SDK where rather than styling separate text views, you can select a subset of a character sequence and apply a style to it. Color, typeface, alignment. And the trade-off is that rather than having the really nice attributes and kind of like being able to visually see what's going on in XML, it's all done through Java code. So here I have an example from that layout where what I do is rather than kind of setting attributes directly on 3 different text views, I am taking some typeface, I'm building a spannable string, and I'm just picking subsections of that text to apply certain typeface to, a certain text color to. And then at the end, all I'm really doing is assigning that entire spannable string, that styled string, to a single text view. And, oops, sorry about that. So what happens is that rather than the linear layout with 3 text views that I had before, I go down to a single text view with some Java code added. So I go down from 4 views and 2 levels down to a single view and a single level. And if you see here, the 3 text views at the bottom are rendered using a spannable. Now, again, you kind of lose that niceness that kind of coherence in your layouts when you're doing and styling everything in XML. But if you have a lot of dynamic text, if you have maybe, again, a lot of dense information, spannables are not a bad technique to use. Unfortunately, they can have problems when you're localizing a lot because those spannables are positioned by are positioned by index in text view. So if you're localizing a lot, you might have to do some tricks or use some other techniques. But if spannables work for you, it's definitely a tool that you should try. Okay, so this is kind of a pet peeve of mine. I know that a lot of times we like to think of layouts as not just kind of building UIs, but also organizational, where we want to maybe like kind of group things in the UI together because we're great software design, engineers. We want to practice great software design and make everything modular and in nice places. But a lot of times that leads me, and I know I used to do this as well, to kind of adding additional kind of layouts that you don't need just to apply like certain characteristics. So at the top here, I have a layout with 3 image views in it. And rather than, so what I did here is that to apply that background, I wrapped rather the layout that's containing, the linear layout that's containing these 3 images in a frame layout. So I can keep everything kind of nicely boxed together and applied a background to it. But I don't have to do that. And I see this a lot. Again, it might be this kind of inclination to kind of organize, but you don't really have to do that. When you have a linear layout and you have this impulse to like, wrap it in another layout so you can apply certain styling or certain layout attributes, don't do it. Just apply those attributes and those graphic kind of stylings to the inner content itself. And, again, it'll save you an extra view, it'll save you an extra level. And, you don't always have to do this. If you're doing this and your layout works just fine, don't worry about it. But if you are having layout problems, if you are having performance problems, just every little kind of layout and level that you can kind of eliminate just helps chip away at those performance problems and chip away at that jank. So just as a quick example, top layout is done with an extra frame layout with the same with a black background. Bottom is done with just applying that black background to the linear layout. Okay, so here's another example of a way to simplify things. So sometimes simplifying involves just picking the right layout, picking a layout that can be more expressive than the ones you picked before. So what I have here is 3 kind of text views that are colored a little bit differently. So what I have here is a purple text view aligned vertically with a blue text view, and then those 2 as a group are aligned horizontally with the larger orange one. So when I was first running Android, I'd probably say, oh, this is easy. All right, I'll do a vertical layout for the first 2 and a horizontal layout to get that first group with the orange one. And again, that's totally correct. It works, it renders just fine, but there are better ways of doing it. So this is what that XML looks like when I do it kind of my easy but naive kind of way. And as you can see, I have 5 views and 3 levels. But if I just pick a different layout, if I picked, say, the new constraint layout, I can take that down to 4 views and 2 levels. So as you can see, sometimes just picking the layout that does what you want kind of easier, and in a sense making it a little bit easier on you, being lazy and picking kind of like the less work for you, can actually make it less work for your application as well. So I wanted to talk about constraint layout specifically because I used to I actually don't like relative layout very much. I never have. Maybe it's because of the double layout pass, or maybe it's because I used to work with people that would instead of using a linear layout, would take a relative layout and just do, okay, this second view above that one, and third view above that one, and fourth view above that one. I could never understand why they wouldn't just use my favorite linear layout. It just makes it easier. But the thing is, relative layout is expressive. It allows you to kind of have these relationships between views. But again, it's kind of not performant. And I think that for different reasons, the Android team has come up with this constraint layout. Now, constraint layout is basically a layout that has a superset of the relative layout features. And it is something that's more expressive, and it's meant to be more performant. Now, I'm going to tell you it's more performant, but it's not in, say, raw runtime. It actually, if you measure kind of the exact same layout between a relative layout and a constraint layout, and just measure numbers, constraint layout is comparable, and in some cases a little bit worse than relative layout. But the reason that it's more performant is that it's more powerful. It allows you to do more things than relative layout and be more expressive, and to position things and develop relationships between views without having to nest, without having to create extra views in that view hierarchy. And really, again, that's kind of what performance in Android layouts is, being able to express things with less layouts, with less nesting, and flattening things out. And as you can see here in my example, the bottom layout is done with the constraint layout, and it has basically the same effect with a lot less nesting and a lot less views. So say that you've used constraint layout, say that you've made lint happy, and you're still having performance problems. Something that you can do, which I also love doing, is writing your own custom views. Now, I'm a custom view fangirl. I love doing them. I do them more than I should, but they are a really good tool. And the reason that they can help you with performance is that when you create your own view group, when you create a layout that where you specifically have total control over how views are kind of drawn to the screen, is that you can mitigate things like that silly double pass that relative layout does, and that actually linear layout does, depending on the situation. And you can do a custom view even, where rather than having something rendered on your screen using multiple widgets, you can do all of the drawing your own and collapse it down to a single view. Custom views and view groups are extremely difficult. They're sometimes feel like they're more trouble than they're worth, and you can probably spend like late nights pulling your hair and trying to get something to render correctly when you could just throw 3 buttons in something and have it work. But a lot of times they can be very valuable tools in solving performance. I actually had this problem myself on a job that I worked like a few years ago, where I think it was like a photo sharing app or something like that, and you could order prints of the photos. And the design we got was like, well, there's different properties, different print sizes and kind of finishes that you can set on each item. And we ended up having individual list items that were just really, really dense with information and that were incredibly dynamic. And we try to do it in a lot of different kind of ways with multiple text views in a single list item and all kinds of other techniques, which worked fine until we started animating it because we wanted to add that swipe to dismiss. And that's when everything started to kind of go like this and like not, look great. It was a really janky experience. And that in that situation where we had so much instance information, custom view groups actually came to the rescue. And actually it was custom views, and I rendered all the text myself, and it animated very smoothly, and it solved the problem. And then the designers refactored everything that I did, and I didn't have to do that anyway. But it still taught me that sometimes if you're in a desperate situation, custom views and view groups can help you out a lot. So, good practices. So, a lot of using efficient layouts and kind of embracing lean layouts has a lot to do with just getting stuff wrong and figuring it out. And a lot of it comes from just experience. And so one of my first rule of thumb for myself is to anticipate and develop good habits. So a lot of times you'll work on one feature or one application, you'll move to the next thing, and you kind of run into problems. Keep those problems in your pocket. Remember kind of like if you have a certain structure that you're building in your UI and you had performance problems with it, remember, and build a repertoire, build a toolbox of things that help you solve that problem. And if you encounter a design where you can see that there's a lot of dense information or there's a lot of animation going on, anticipate, understand that might cause you a problem, and to try to kind of cut the problems off before they start. A lot of it is just picking the right solutions to begin with and picking the simplest solutions. It's all about, with layout performance, all about reducing, again, the number of views and reducing the depth of that hierarchy, reducing the complexity, and making those measure and layout passes as simple as possible. Fewer and flatter. So a tip that actually Chet Haas and Romain Guy from the Android team gave last year, which I think is kind of funny, not to rag on relative layout again, but at the Android Dev Summit last year, they kind of gave this talk called The Naughty Bits of Android, and they specifically said, don't use relative layout at the root. And that's basically because, again, the relative layout double pass, the kind of hit that you take from that gets multiplied the higher and higher up these layouts are in your view hierarchy. So again, flattening that out helps as well. Picking the right views, like not relative layout at the root, also helps with that as well. And again, just stuff that you kind of learn as you kind of build your UIs and experiment and kind of measure the performance. Another thing is to don't let problems accumulate. We're all in teams, we have to ship code, we have deadlines. Sometimes you just can't build your perfect little efficient little castles. But sometimes you can. Or sometimes you might have a break, or sometimes you have a chance to reevaluate kind of the state of your UI when you're adding a new feature. Basically, kind of always have it in mind. Of course, we always have to get code out, we have to get features done, we have to kind of move the code forward. But whenever you have a chance, kind of take a look, evaluate. If there's a place that you can be more efficient, do it. If not, try to do it again for the next time. And overall, just balance performance gains with development effort. I mentioned things like custom views and things that kind of have a high learning curve and things that are a little bit complicated to get into. but that can solve your problems. Now, those are great things, but again, you always have to kind of be pragmatic about it. Like don't over optimize. Like if your code's running fine, forget everything I said today. But if it's not running fine, that's when you evaluate and benchmark, test your code, use metrics, really kind of analyze. Don't, I personally am a very lazy developer. And even though I love all this stuff, if I don't have to refactor something, I won't. And again, that's kind of the strategy with lean layouts is that we have all these cool techniques, we have all these things that we can use, but use them when you need them. And that's pretty much it. Thank you so much. Sorry, just quick plug. I actually, with a friend of mine, run a channel where we interview people in the Android community and talk to them about the cool stuff that they're doing. Please take a look if you're really interested. Yeah, that's it. I'll have the slides up on speaker deck. And if you're a Trello fan, I have stickers, so please come and find me afterwards. Thank you very much.